Hi, I'm Tim Marran, the product manager for chainflex cables here at igus Inc. Today, we're going to talk about the 7 basic rules for a good continuous flexing cable design. Why is this important? Well, when it's inside of a cable carrier application, the design of the cable is extremely important because we need to consider taking on those mechanical forces and the fact that the cable will need to stand up to many, many cycles. Let's take a look at what those elements are now. The first design element we use is a high tensile strength center element. And what this does is it absorbs the mechanical forces incurred during continuous flexing. That way, those forces aren't on the conductors themselves, giving you a longer life of your electrical cable. The second design element we employ is an optimized conductor structure. This is where we use a very specialized stranding. If it's too thin or too thick in a mechanical moving application, those strands would break down relatively quickly and cause electrical problems. At igus, the number of strands as well as the thickness is extremely important in our design for mechanical ability, and we test this at our in-house test lab. The third design element is a high-quality insulation material. In principle, the insulation material directly surrounds the copper conductor to contain the electrical current. At igus, we use a very abrasion-resistant material because inside of a moving application, while the cable is installed in an energy chain, those conductors will actually move ever so slightly against each other. And so if you don't have an abrasion-resistant material for the insulation, they will wear down over time. The fourth design element is the overall cabling. At igus, we use a short pitch length or twist to the individual conductors. What this means is when the cable is in the radius of the cable carrier, it allows for dispersion of those mechanical forces evenly around all the conductors. Additionally, igus also uses the bundle design, which is where we pre-group smaller number of conductors together before we bring them all together in one final manufacturing step. This bundle design allows for the further dispersion of mechanical forces, and also it helps prevent corkscrew, one of the main failures we see in continuous flexing applications. The fifth design element for a good continuous flexing cable is the gusset-filled pressure extruded inner jacket. What this means is we use our inner jacketing material to fill in all of the gaps and crevices between the conductors on the cable. What this allows for is creating a channel for each individual conductor so that it doesn't have any room to move underneath the overall jacketing and cause further damage and other issues such as corkscrewing. The sixth design element that we use for a good continuous flexing cable is tinned copper braided shielding. At igus, we use a low angle or tight angle braid for our shielding. What this does is it provides 2 different things electrically. 1, protection against EMI, or electromagnetic interference, commonly called noise, and 2, it provides 70 to 90% optical coverage. Additionally, the tight angle braiding also stands up better mechanically in a continuous flexing application. That's how igus can guarantee our shielded cables for millions and millions of cycles. The 7th design element is a good jacketing material. The jacket for any wiring cable is there to protect against environmental factors, such as temperature, oil resistance, coolant resistance, things like that. At igus, while taking those things into consideration, we also think about high abrasion-resistant materials. This is because we know our cables will need to last for millions of cycles in a cable carrier application, where it might come in contact with other cables, parts of the cable carrier, as well as other parts of the machinery or equipment. To find out which jacket material might be the best for your application, please click on the link below. Additionally, now that we've covered all of the 7 design elements, you can look to see if maybe one of the other 6 could also help you extend the life of your cable for your application. At igus, these 7 design elements have really helped us be able to guarantee our cables for up to 10 million cycles, and on some other cables up to 100 million cycles. Additionally, these are the design elements that we use to make sure that our customers don't have to deal with many different cable failures that are common in the industry, such as loss of continuity from broken conductors, insulation damage, jacket cracking and swelling, as well as the main one, corkscrewing. So thanks again for learning with us on what the 7 different design elements are for a good continuous flexing cable, and we hope to see you in the next video.